Hello everyone, welcome to Young Minds versus Physics. Yes, don't start solving vectors before watching this. At 11th and 12th standard, we must be familiar with all this from vectors before we start solving the numericals. Polar vectors and pseudo vectors. Polar vectors have linear directional effect, also called as true vectors. These vectors have an initial point and a point of application. Like when we speak about displacement, velocity, acceleration, momentum, force, etc., which we usually learn in kinematics, force, friction, and all that. All these are polar vectors, right? These are also called true vectors and they have linear directional effect, right? And the other kind is pseudo vectors. So these vectors have rotational effect. These are also called axial vectors. Now suppose, if a disk is moving in anti-clockwise direction like this, that means it is rotating. And now this is rotating about a particular axis. Then the direction of pseudo vectors is along the axis of rotation. If you talk about a polar vector, which is a linear velocity, this acts along the tangent drawn to this circular path, right? And this is having a linear direction. Whereas when the body is in a rotational motion, so the pseudo vectors act along the axis of rotation. Example, angular displacement, angular velocity, angular acceleration, angular momentum, torque, etc. All these we learn in, yes, rotatory motion or what we call a circular motion or rigid body dynamics. So now is it clear? Polar vectors are the vectors which have linear directional effect and pseudo vectors which show rotational effect, and all the linear vector quantities or the physical quantities are polar vectors, and all angular quantities like angular displacement and so on are pseudo vectors. You might have come across some other word, tensor. Yes, it's very common that you will get confused between a tensor and a vector. So what is a tensor? Tensor is neither a scalar nor a vector. Then what it is? At this level, right, at 11th standard, we must know the basic difference between a tensor and a vector. See, tensors also have direction and magnitude, like electric current. So when you speak about electric current, the physical quantity, whether it is a vector quantity, then it is not a vector. It has direction and it has magnitude, but still it is not a vector. Why? Because it does not obey laws of vectors. This is a tensor. So tensor is the one that has direction and magnitude. Tensors have different values in different directions, but they do not obey laws of vectors. Like examples are electric current, stress, the force that you are applying on a particular area of a body, the stress experienced by the body or acting on the body. Yes, that is a tensor. Moment of inertia. So when you discuss moment of inertia and rotatory motion, inertia of a body, right, a rectangular lamina or a rectangular plate along the axis parallel to the length or along the axis perpendicular to its thickness, right? So these are all the things like where you are talking about along a particular axis. That means here you are giving a directional sense to moment of inertia. But it is not a vector quantity. It is a tensor. Now representation of vectors. I know you are all very familiar with this. Right? A vector is represented like by an alphabet with a bar on its head, or can be an arrow mark, or with two alphabets to put together, like each alphabet representing a point, the initial point. Here it is the initial point and this is the final point or the terminal point, where we call this as a head and this as a tail. And with a bar on the head of A and B together, put together, that represents a vector like AB bar or vector A bar. And in pictorial representation or graphically, so we always represent a vector with a line segment, right, and with an arrow mark, right, giving the direction of the vector, Example, suppose if it is displacement, you may write it as S bar, for force F bar, velocity V bar. So whenever you find a bar on the head of any variable, it means that it is a vector quantity. Now coming to the size of the vector, that we call as magnitude of the vector, is always represented by modulus. Why? Because the value of the vector is always positive. It is always positive. So thus modulus of A bar or modulus of AB bar gives you the magnitude of the vector, or what we call as size of the vector. Means, yes, it is the length of the line segment. It is the length of the line segment which is representing the vector. So magnitude means length of the line segment representing the vector, or rather we say here as the size of the vector, which is always positive. Right, when you go ahead in the derivations, you will simply see that modulus of A bar can be written just as A, or modulus of AB bar as just AB. And you know mathematically what is meant by AB. AB is the distance between the points A and B, the smallest distance between the points A and B. And that is the magnitude of the vector. That is the magnitude of the vector. When we talk about addition of vectors, right? When we talk about adding vectors, here I am taking the example as more than two vectors we are adding. That means on a body, right, or on a point, or yet a point, when three vectors A bar, B bar and C bar are acting in the directions as specified here. Now how are we going to add them and find the resultant vector? Add them and find the resultant vector. So now just take this as the point of application or the starting point of the first vector. Let us name it as O. Right, now draw the direction. The same vector here is shifted here. It is just shifted here. It's a parallel shift of the vector. See, the same vector in the same direction, right? And these two, if you extend, they will be parallel to each other, right? With the same magnitude and direction here, we are redrawing the vector A bar. And from the head of this one, you are starting the second vector B bar parallel to the given vector. And again, from the head of the second, you are going with the third vector parallel to the given vector. So thus you have the vectors A bar, B bar and C bar, and here we go with the resultant R bar. Have to understand this very easily. You can take the example of a displacement that gives you a very clear picture in the mind. See, suppose if a person is displaced from O to A, then from A to B, and again from B to C. Now, what is the final displacement? What is the net displacement? Or rather, what is the resultant displacement? Then the resultant displacement is from the initial point of the first vector to the final point of the last vector. Very clear, is it not? Yes, it is that simple. It is that simple. The only care that you have to take is that when you are redrawing the vectors, those vectors should be the vectors parallel or equal vectors to the given vectors. So here A bar is equal to the A bar over here. Right? So now R bar can be represented as sum of A bar, B bar and C bar. Thus we write it as R bar is equal to A bar plus B bar plus C bar. Right? Now suppose I am taking two vectors which are acting mutually perpendicular directions and I want to find the resultant. Right. So I can just simply draw the diagram like this while solving the problems, right? Is just draw this one in a rough space and use the least or the smallest space that whatever you can use. Draw the vectors. Like suppose two vectors are given which are acting at a point in mutually perpendicular directions. Right. So this is OA bar is one vector, AB bar is another vector. Right. So these two are acting perpendicular to each other. Right. And then now this is the direction of the resultant, which is OB bar. Right. The same thing, like how mathematically you are doing it as along the two sides of the right angle triangle and the resultant is along the hypotenuse. Very easy to understand this. Now the same geographically if you are talking about. That means sometimes you will find in the problem saying that a man is heading towards east. After a displacement of 5 meters, he is heading towards north. So now this is the same. Like starting from O, the man moved to A, covering a displacement of 5 meters. And again, he changed his direction of motion towards north, that is from A to B. Now he moved by a distance of 5 meters. Now, what is the net displacement? What is the net displacement, or from where to where, in which direction did the man move? So this is the way that you have to understand in solving the problem. So this is towards, like say, take this as an origin, and towards the right hand it is east, above it is north, onto the left west, and just below the north downward direction it is south. So therefore, when the problem reads like a man is heading towards east, this is the direction. And when he changed his direction to north, this is the direction. And now very easily you can apply the direct concept of resultant and then find out this one. Now this is 5 meters, this is 5 meters. I know pretty well that you all know that this is 5 root 2. So what is the net displacement? The net displacement is 5 root 2. In which direction is it? Exactly, it is making 45 degrees, is it not? So y by x, it is 1, tan 45 is 1. So therefore, it is 45 degrees of angle. Thus, it is in which direction? Northeast direction. This is in northeast direction. So the resultant is 5 root 2 in northeast direction. The same problem. If it is asked like in xy plane or in a coordinate plane, Like how does it look like see, this is positive x-axis, this is negative x-axis, positive y-axis and negative y-axis. You have the unit vectors along x as I and negative x as minus I cap, and along positive y it is plus j cap, and along negative y it is minus j cap. So now along positive x direction, 5 meters of displacement. Now change in the direction. It's moving along positive y direction, and the displacement here is 5 meters. So along ex it is 5i cap. Along y it is 5j cap. Sum of these two vectors is the resultant. See, I only have represented it. And you all know how to find out the magnitude of it, right? Root of 5 square plus 5 square, it is 25 into 2 under root or 5 root 2. So this is how you can solve. See, this is how you can directly do using Pythagoras theorem. And here, like geographically, like if the directions are asked and if it is along the Cartesian coordinate system. Now subtraction. See, now here two vectors are acting again like in mutually perpendicular directions. So our motto here is not to add but to subtract. See, I have redrawn the vector A bar here between O and A. Of course, A bar between A and capital B. Right? So I have two vectors here. Now you know pretty well that this is the resultant. From O to B is the resultant. But here what we want is subtraction. You know very well that subtraction is adding the negative of a number to the given number. The same concept is here. Adding the negative of a vector to a given vector gives you, the resultant gives you the subtraction of second vector from first. So, I want to draw a negative vector. What's a negative vector? A vector with the same magnitude but opposite direction. See, I'm just drawing another vector which is quite opposite to B bar. So let me draw it like this. Let me draw it like this. So this is the negative vector. So this is minus B bar. So now if I forget about these two, and if I observe that minus B bar is acting here, A bar is acting here, use your common sense. So where will be the direction of the resultant? Definitely that means if you are trying to push a body like one in this direction and the other force in this direction, absolutely body moves like this. Isn't it? So the same is happening here. Now we have to see whether whatever common sense is saying is the same as what the physics is saying. See now minus B bar, A bar. Now from O to A and again A to some point C here. So what is the resultant? This is the resultant. This is the resultant. Absolutely. Yes. What your common sense is saying, the same physics is also saying. So my dear young minds, use your common sense whenever you solve problems. The same can be done in geographically, like let us suppose that a vector is acting in the east direction, the other one in the north direction. So subtraction of the vectors means if you want to subtract the vector which is acting in the north direction from this, you have to draw a vector which is a negative of the second vector. In which direction? Yes, in south direction. And now if these two are of equal magnitude, this is going to be the resultant. Right. Now here, sum of the vectors, suppose if I draw a parallel vector here, that is an equal vector here, this will be the direction of the sum of the vectors. If I take A bar and B bar, this gives you A bar plus B bar. But whereas this gives you A bar minus B bar. A bar minus B bar. See, now this and this, these two are same in magnitude. A bar plus B bar and A bar minus B bar in this particular case, where two vectors are acting in mutually perpendicular directions, right? Magnitudes are same, but here it is in the northeast direction. Sum of the vectors, the resultant of sum of the vectors is in northeast direction, and the resultant of difference of the vectors is in, yes, southeast direction. It is in southeast direction. Same, let us look here, right? See, this is along, right? If I take A as the magnitude of the vector, AI cap in this direction, and if I take it as B magnitude of the vector, Bj cap in this direction, now what will be the resultant of the sum? The resultant of the sum is, let me write it as resultant of sum is equal to, this is in vector form, Ai cap plus Bj cap. Ai cap plus Bj cap. And if at all I have to find out the subtraction, like I have to draw the negative vector of the second vector or the vector which I am going to subtract from. So here magnitude is B only. Magnitude is B only. What is that which is defining is direction is this j cap. Now it is minus j cap. Now this is the resultant of the subtraction. This is the resultant of subtraction. So let me write it as R sub bar. Right? R sum bar, R sub bar. So now this is Ai cap plus B of minus j cap. Why? Because here the direction is defined by the unit vector. This is just simply magnitude. So this gives you Ai cap minus Bj cap. Yes, this is about subtraction. Now suppose if there are number of vectors given like this. Can you observe the directions here? So two directions are away from the point of application and one is towards it. Right. So now here draw the vector equal vector A bar, negative vector minus B bar. Can you observe? These two are parallel, but the direction is opposite. Direction is opposite. What is such a vector called? Anti-parallel vector with the same magnitude. We call it to be the negative vector. Anti-parallel vector with a negative. That means here with the same magnitude, we call it to be minus B bar, which is a negative vector. And from the head of this one, you are now moving on to the third vector, equal vectors. So A bar, C bar are equal to the given vectors, where minus B bar is the negative of B bar. And now can you see the resultant? Suppose if it is from O to A and again A to B and then again B to C. From the diagram it is very clear from O to C is the R bar, the resultant. This is how you can apply the concept of subtraction of vectors, or rather we can say that the concept of negative vectors. So it is A bar plus of minus B bar plus C bar, that is A bar minus B bar plus C bar. Angle between two vectors. See, angle between two vectors is always angle between the directions. Simple. So don't get confused. Don't think too much. So angle between two vectors is angle between their directions. That means both the vectors should have direction away from the point of concurrency, or from the point of intersection, or from the point where they meet. So here it is. Theta is angle between A bar and B bar. Now suppose if angle between A bar and B bar, this is B bar. Observe carefully. This is B bar, this is A bar. If this is alpha, now how do you find out the angle between A bar and minus B bar? A bar and minus B bar. Minus B bar means you should draw a negative vector. Let me draw an anti-parallel vector with the same magnitude. This gives you minus B bar. This gives you minus B bar. That means, now observe the same hint what I said here. From the point of intersection, both the directions should be away from. Now you see these two are away from. So therefore, this is the angle between A bar and minus B bar. Yes, my friends. So what is that? It is 180 minus alpha. So this is how you have to understand angle between two vectors, right? What is the hint? Angle between two vectors means it's just angle between their directions, and the direction should be something like from the point of intersection or from the common point of the vectors. Both the vectors should have same direction. That means the direction should be away from the point. The direction should be away from the point. You are not supposed to take like minus B bar. Now you join these two, and this can't be the angle between A bar and minus B bar, because here see, this is towards and this direction is away from. Okay, so this is the basic angle definition, that is angle between two rays. The same is applicable here. Now, as a final touch-up, types of vectors, unit vector, from the name itself it is very clear. A vector whose magnitude is 1, whose size is 1 is called unit vector. Usually standard unit vectors are I cap, j cap and k cap. And you can also, like, depending on a particular vector, unit vector in a particular direction can be A cap, B cap, C cap, like that. Then next one is null vector. Yes, very, very important this one. Null vector is a vector whose magnitude is 0. Then how are you going to represent it? How are you going to represent a null vector? It is the bold alphabet, right? So usually null vector is a bold 0 or bold O. And then graphically or pictorially we represent the null vector with a point, with a single point where the starting and the final points are the same, right? So whenever you speak about net displacement is 0, net force is 0, net velocity is 0, at such points you will represent that as a null vector, right? Equal vector. Right now already we have seen what an equal vector is. If the directions are same as well as the magnitude is same as the given vector, it's an equal vector. Negative vector, direction is opposite but magnitude is same. Coplanar vectors which belong to the same plane. If you take the plane of the paper, right, the vectors, all the vectors which belong to that plane are called coplanar vectors. Parallel vector, you have seen now how we are drawing the vectors parallel to each other. That means the direction should be same. Direction should be same. Anti-parallel vector, absolutely direction of the other vector should be opposite to the given vector. All the vectors are along the same line. When all the vectors are along the same line, they fall along the same line, we call them as collinear vectors. And here concurrent vectors, just now what we discussed, that is the point of action of vectors is the same, then we say it to be concurrent vectors. The vectors are concurrent vectors. So All these are the things which help you a lot in understanding the problem and solving the numericals. This is all for today. Have a nice day. See you.